This is a video tutorial for tutorial 5A question 9. 5A question 9 asks us to find dy dx for the following functions. The first function it wants us to find it for is x to the power of 2/3 plus y to the power of 2/3 equals to 1. So how do we do this? Well, this is a question involving implicit differentiation, so we're just going to go and differentiate both sides with respect to x. What does that give us? Differentiating x to the power of 2/3 with respect to x gives us 2/3 x to the power of negative 1/3, bringing the old power down, decreasing it by 1. Plus, same thing for y, 2/3 comes down the front, y to the power of negative 1/3, but then we have to differentiate the inside, which means we get a dy by dx appearing out the back. That's going to be equal to 0. So how do we do this? Well, we just want to make dy dx the subject of this equation. So I'm just going to leave the dy dx on the left hand side, move everything else to the right hand side. So we get 2/3 1 over the cube root of y, so 2/3 times 1 over the cube root of y times dy by dx equals to negative 2 over 3 times 1 over the cube root of x. Okay, so I can see straight away the 2/3 are going to cancel out here. Move that y over, I get dy by dx is equal to the cube root of y over the cube root of x. I could also write that, sorry, it should still be a negative there. This is also equal to the negative cube root of y over x. So that is my expression for dy by dx. Let's move on to 9b. 9b wants us to differentiate or find dy dx for x squared y squared equals to x plus y. Okay, how do we do this? Well, again, we're just going to differentiate both sides with respect to x. And what does that give us? Well, we need to apply the product rule on the left-hand side. So we will hold the x squared constant. Differentiate y squared, we get 2y to the power of 1, so decreasing the power by 1, then multiply by the derivative of the inside, which is going to be dy by dx, plus hold y squared constant, differentiate x squared, you get 2x. What about on the right hand side? Differentiating x, you get 1, differentiating y, you get dy by dx. So now we're going to try and bring all the dy by dx to the left hand side, or everything else to the right hand side. So 2y x squared dy by dx minus dy by dx is equal to 1 minus 2xy squared. Factorizing out dy by dx, we get 2x squared y minus 1 dy by dx is equal to 1 minus 2xy squared. And so dy by dx is equal to 1 minus 2xy squared over 2x squared y minus 1. So that brings us to the end of 9b. What about 9c? This time we've got x to the power of n plus y to the power of n is equal to k xy. We're told n and k are both constants. So again, we still need to find out what is dy by dx. So we're going to differentiate both sides with respect to x. What does that give us? So differentiating x to the power of n, power comes down the front, decrease the power by 1. Same thing with y, power comes down the front, decrease the power by 1, multiplied by the derivative of the inside with the chain rule. So dy by dx appears out the side. What about here? Still get k. Then product rule for this, so hold x constant, differentiate y, you get dy by dx, plus hold y constant, differentiate x, you get just 1. So this is what we get after differentiating once. So what do we do now? Again, same drill. We're going to try and bring all the dy by dx to the left-hand side, everything else to the right. So this, let's first just expand out that bracket. So that's kx dy by dx plus ky. So moving that to the left-hand side, this to the right, we get ny n minus 1 dy by dx minus kx dy by dx is equal to ky minus nx to the n minus 1. So factorizing out dy by dx, we get ny to the n minus 1 minus kx, whole thing multiplied by dy by dx, is equal to ky minus nx to the n minus 1. That gives us dy by dx equals to ky minus nx to the n minus 1 over ny to the n minus 1 minus kx. And that brings us to the end of question 9.